All right. Hello, hello. Um, so today we took the practice state test in class, and for our intervention period, I wanted to be able to go over it. So, um, so I'm making this video so that you can follow along. These are the same questions, to my knowledge, that we had on the practice test. Um, because it looks like the questions that I was seeing when I was walking around and watching people. So I'm going to go over every single one of them, and that is the plan for the intervention period. Okay, so let's start with question one. Question one: Triangle ABC has vertices A 0, comma 1, B 2, comma 5, and C 6, comma 3. Triangle A prime, B prime, and C prime is created by reflecting triangle ABC over the y-axis. And it says, what is the x-coordinate of vertex C prime? Okay, so what this is doing is this just wants you to reflect one point over the y-axis. So when we talk about reflections, right, reflections are a flip. Back when we did the transformation unit, we usually had the graph in front of us. It would be like if you had a graph here, and you took a triangle here, and you reflected it, and it became a triangle over here. Okay. So, the rules that we used for reflections is that if you were reflecting over the x-axis, you had to change the sign of your y. X comma y becomes x comma negative y. If you're reflecting over the y-axis, x comma y became negative x comma y. All you would do is you would just change the sign of the opposite letter. Now, what you could do here is that you could use the clues the question is giving you. Okay? It's only asking you for the x coordinate of the point. So you can assume that because they're going to ask you for the x coordinate, that the x coordinate is the one that's going to change. Odds are they're not going to give you a question where the number is not going to change and just be like, rewrite the number. You know? So if they only ask for one coordinate, whether that's the x or the y, assume that's the one that's going to change. Unless you know for a fact it's not. Okay, so my point is 6 comma 3 for C. So I'm going to negate the 6. I'm going to just make it negative. I'm going to change the sign. So your answer is negative 6. That's question 1. Let's move right on. Question 2. Which table represents a non-linear function? So think about what the word linear means and think about what the word non-linear means. Okay. Non-linear, prefix non, means not. And linear usually means a line, a straight line that we would use in the form of y equals mx plus b, where m is your slope and b is your y-intercept. And what's important here is m, your slope. And why it's important is because in any linear function, your slope is constant. Think about what the word constant means. It's not changing. Okay? Your slope remains the same for every point between 2 points. Okay? For every line segment between 2 points, your slope will always be the same. So here's what you're going to do. You're going to go to each table. Remember, your slope is your change in y. Change in y over your change in x. So we're going to see how our x is changing. For this first table, negative 1 to 1, we added 2. 1 to 4, we added 3. 4 to 10, we added 6. On your y side, 3 to 5, we added 2. 5 to 8, we added 3. 8 to 14, we added 6. Okay? So, on this left side, you can see your slope is 2 over 2, which is 1. Here, it's 3 over 3, which is 1. Here, it's 6 over 6, which is 1. So, let's look at B, because this slope stays constant. B, 0 to 4, we're adding 4. 4 to 6, we're adding 2. 6 to 9, we're adding 3. 0 to 12, we're adding 12. 12 to 18, we're adding 6. 18 to 27, we're adding 9. Let's calculate our slopes. Change in y, 12, over change in x, 4. That's a slope of 3. Change in y, 6, over change in x, 2. 6 divided by 2 is 3. Change in y, 9, over change in x, 3. That equals 3. All of our slopes are 3, so it's not B. Let's go to choice C. 2 to 5, that's adding 3. 5 to 7 is adding 2. 7 to 11 is adding 4. Negative 3 to negative 9, that's subtracting 6. Negative 9 to negative 13 is subtracting 4. And negative 13 to negative 21 is subtracting 8. So now we figure out our slopes. Here we go. Change in y, negative 6 over 3. You can even put this into your calculator. Negative 6 over 3 equals negative 2. Our next one, negative 4 over 2 is negative 2. And then finally, negative 8 over 4 is also negative 2. So all of our slopes here are negative 2. So C is incorrect. So at this point, we now know it's D. But let's, just for fun, take a look at it. 2 to 4, that's the difference of adding 2. 4 to 8, you're adding 4. 8 to 10, you're adding 2. 5 to 17, you're adding 12. 17 to 65, ooh, those are big numbers, so let's double check with our calculator. That is adding 48. And 65 to 101, that's 101 minus 65, that's adding 36. So our slope here, 12 over 2, that's 6. 48 over 4, uh-oh. 48 divided by 4 is 12. That slope does not match. So your answer is D. It's choice D, because it does not have a constant slope. All right, question 3. Scatter plot is shown. Which statement about the scatter plot is true? Now, we're going to be going over scatter plots in math class today a bit, is my plan. But here's the long and the short of it between a scatter plot. Okay. First off, there's two things you need to know. Linear association versus nonlinear association. And whether it's positive or negative. Okay. So linear association is the idea of, can I pretty much make a straight line that goes through most of these points? And the answer is yes. I can make a straight line that goes through most of these points. A nonlinear association would look something like where you have points here, 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 here. That's nonlinear, because there's no line that really works with this. This, you can kind of trend towards a line. it looks linear. Also, there's a difference between whether it's positive or negative. This is exactly what you think it is. If it's trending upward, if you draw your line like this and the line's going up, it's positive. If it's going down, it's negative. So for this one, it would be C. There is a negative linear association between X and Y. All right, let's go to 4. A candle in the shape of a cylinder has a dimension shown in inches. What is the volume in cubic inches of the candle? Round your answer to the nearest hundredth. So, first thing we need to remember is our volume formula. If you are on your state test, there's a formulas button at the top of the screen that will show you the volume formula. I just happen to know it offhand. So, volume equals pi r squared h, radius squared times height. So first thing we have to identify, what's our radius, what's our height? Height, that's easy enough, 8 inches. When you think of height, you think of like how tall you are when you stand up, right? What's your height? I'm 6'1". That's my height. That's how tall I am. So we're going with 8 here. Radius, this is tricky. So remember, we talked about the circle. Okay? And we talked about the 3 kinds of lines in circles. There are chords. That's any line that goes from one edge of the circle to another. There are diameters. That's any line that goes from one edge of the circle to another but passes through the center. And then there's a radius, which is any line that goes from the center to an edge of the circle. So this whole thing is a diameter. This is a radius. Okay? Your diameter is equal to 2 times the radius, or your radius is equal to 1/2 the diameter. Here, and you can't see it very well on this picture because of how I printed, but that's fine. So I'm going to draw the line here. You see the line going all the way across. It goes all the way across the circle. And it says that's 5 inches. So that means that that is the diameter. If the line goes all the way across the circle, it is the diameter. So you have to have it. What is half of 5? Well, let's do 5 divided by 2. And you get 2.5. 2.5. Perfect. Okay? Now, from here, you can just type it in exactly as you see it. Because it tells you you're rounding to the nearest hundredth. So you know you're multiplying this all the way. So let's type it in exactly as we have it. We have pi, parentheses, 2.5, close parentheses, squared, parentheses, 8, close parentheses. You notice that I'm writing it in the calculator exactly as I have it. Enter. 157.079. Okay? So we have to round to the nearest hundredth. The state test loves to have you round to hundredths, so you should know where your hundredth is. Your hundredth place is 2 places after the decimal. So this 7. That is your hundredth. So we're going to round that either up or down based on this 9. Remember your rules for rounding. 5 and above, give it a shove. Okay? 9 is 5 or above. So we're going to push up the 7 to an 8. So our final answer will be 157.08 inches cubed. All right. Question 5. Select all the equations that represent a nonlinear function. And they give you 5 different equations here. Now, first thing, select all. Select all usually means more than one correct answer. I'm not saying there's a situation ever where there's only one correct answer, but I would say probably 19 times out of 20, it's going to be more than one correct answer. Okay. So let's go into this thinking that we're going to have more than one correct answer. So when we talk about what makes a linear function linear, right, we want something that can be written in the form y equals mx plus b. To get to that point, we have two rules that we have to follow. One, there can be no exponent on x or y. There cannot be an exponent on x or y. Rule 2, x and y must be on opposite sides of the equal sign. And not in a denominator. If they give you an equation like x plus y equals 3, you can make that into a linear equation by moving the x over, and you would end up getting y equals 3 minus x. And that's a linear equation. So if you have a situation with rule 2 where x and y are on the same side of the equal sign, then see if you can move it over without putting x or y in a denominator. Because, for example, if they gave you one like xy equals 3, the only way to move it is now dividing by x, and you would get y equals 3 over x, and that doesn't work. That's not linear. Okay? So let's check our rules. Number 1, y equals 3x squared. Stop. 3x squared. That's a nonlinear function. 2, y equals 3x minus 10. That's already in the form of y equals mx plus b. So that's a linear function. We don't check it. 3, y equals 2x plus 9 plus x. So that doesn't look like a linear function because we have two x's. However, this is just combining like terms. Remember, when you combine like terms, that you're only adding or subtracting. Okay, so this 2x plus x would become 3x plus 9. That's fine. It's linear. 4, y equals x parentheses 3x plus 10. This uses distribution. This is different from the above problem because distribution, remember, is always multiplication. What do you get when you multiply x times 3x? Well, you get 3x squared, and now we have an exponent, so that doesn't work. That's not linear. And finally, 5. Y equals x over 3 plus 10. This is, again, fine. This is a line that has a slope of 1/3 and a y-intercept of 10. You can have the x in a numerator. X just cannot be in a denominator. So your answers are these two. Okay? Let's go to question 6. Question 6 is an interesting question for me. It's even one that when I looked at the practice test, I was intrigued what Ohio thought was the easiest answer. So let's just go with it. Okay, here we go. A figure is shown where triangle ABC is similar to triangle ADE. Similar, right? Means that they have the same angles, they don't have the same side lengths. It's a dilation. Okay? The location of point A is 1.2, 2.1. And this is an interesting thing to know because they're using decimals in points, so they're trying to throw you off immediately. The lines connecting points A, B, and D passes through the origin. This is also very important because what this tells you is that your line goes through 0, 0, which means it has a y-intercept of 0. Okay? So that says, what is a possible ordered pair point for point D? So what they give you is they give you the distance between point A and C and the distance between point B and C. They're giving you the slope. This is your rise over your run. This is your change in y over your change in x. So if A is at 1.2, 2.1, C would be 4 away, right? Which would be at 5.2, 2.1. And then B would be 7 up from C, which would be 5.2, 9.1. Okay, so they're asking you what any point you could be for D. So here's how you could look at this. A, you could look at this as an equation of y equals 7 over 4x. We know it's a y-intercept of 0, so there's no additional y-intercept. It's just our slope, 7 over 4x. And you can put in any number for x higher than 5.2. Because remember, this is at 5.2. So this has to be past it. Okay? So you can put in, I don't know, say 6, right? Or even 8. 8 would work. So if you put in 8, you get y equals 7 over 4 times 8. So let's do that. 7 over 4 times 8 is 14. And that gives you a point of 8, 14. And this answer is actually the one that the state says is the correct answer. And the reason that they find that this is the easiest is because all you're doing is you're starting at 1.2, right? And you're just doubling your slope. I'm sorry, you're starting at 0, 0, and you're doubling your slope. Okay? So you know your slope is 7 over 4. So you go over 8, up 14, and you get 8 over 14. Okay? You could start at A, go 4 more. That would give you 1.2 plus 8 would be 9.2. And then go up 14. So going from your starting point of 2.1, that would be 16.1. Which, yeah, you could use this. This is admittedly a little more confusing. I think the reason they go for 814 is because of this line. It passes through the origin. Okay, so that means you could just start at 0, 0, apply your slope twice, and get 8, 14 and call it a day. This is a very confusing question, and I understand my explanation on this video was not the best. So if you want me to re-go over this question during class, I can absolutely do so. Just let me know, and I will do that. Because that question is wild. All right. Question 7. An expression is shown. 2.1 times 10 to the 5th plus 4.3 times 10 to the 4. So let's try this. Let's try putting this in our calculator. 2.1 times 10 to the 5th plus parentheses 4.3 times 10 to the 4. And you may ask, Mr. Dietz, why did you put that in parentheses? Just because the calculator, you want to make sure it's doing the multiplication first. It's doing the 4.3 times 10 to the 4 first. So you want to make sure that you keep this as numbers. And we hit enter. It tells us 253,000. Okay. So this immediately eliminates choices C and D. Why? Because it's not 253,000. So now let's go to our calculator again. Let's put in 2.53 times 10 to the 4. That's 25,300. Does that match? No. Cross it out. 2.53 times 10 to the 5. And what do you know? 253,000. Hot diggity dog. It's there. It's done. This one, just use your calculator. If you wanted to not use the calculator, you could remember that when adding numbers in scientific notation, your exponents need to match. So you would have had to use LARS, which is left add, right subtract. And you would have had to adjust one of your decimals, one of your exponents to make them match. If you remember during class way back when we did this, I said I personally like to move the smaller one, the smaller exponent, because odds are your answer will be in scientific notation if you do. So we need to make this 4, match this 5. We do so by moving our decimal to the left one to add. So you would have 2.1 times 10 to the 5th plus 0.43 times 10 to the 5th. And then you just add these two numbers. 2.1 plus 0.43 equals 2.53. And then your exponent remains the same. So that's how you can actually do it. Or, if the calculator works, use the calculator. I don't care how good you are at mental math, use your calculator. They give it to you. It is a resource. It is not a crutch. It is a resource. Use it. Question 8. A diagram with line M parallel to line N is shown. Express the value of y in terms of x. Okay. Ooh, we need to pick it up here. I just looked at how long this is taking. So, express the value of y in terms of x. So, remember when we did parallel lines cut by a transversal? Okay. The big rule that everybody remembered, for the most part, was corresponding angles, which is angles that are in the same spot on the line. So this y, right here, would correspond with this, because they are both in the top left position of their respective intersection. So we know that this is y, because that's congruent by corresponding. We now know that this is a straight angle. Straight angle adds up to 180 degrees. So we know y plus 3x plus 10 equals 180. And now it says, express the value of y in terms of x. What does this mean? It means solve for y. What does that mean? Get y by itself. And you can figure that by the fact that in your answer box, they already put y equals. So, let's move some stuff over. I'm going to start by moving to 10. Draw your fence, if that helps. We're going to subtract 10 from both sides, because remember, we're going to the opposite side of the equal sign. So opposite sides means opposite signs. 180 minus 10 is 170. And then we're going to subtract 3x also. We can combine 170 and 3x, because 3x has an x, and 170 does not. So you would just have 170 minus 3x. And that would just be your answer. That's it. All right. Question 9. Which graph represents a function that is decreasing at a non-constant rate? Okay. So, decreasing. Let's look at our keywords. Decreasing. Going down. Are any of these lines not going down? A is not. D is not. Because remember, it's always going down when being read from left to right. So that leaves us with choice C and choice B. Non-constant means that your slope is changing, meaning it's going to not be a straight line. If it is a straight line, it is a constant rate. So that disqualifies B. Our only answer left is C. It has a curve. If you see a curve, it means it's non-constant. So your answer is C. Question 10. Select a box to identify whether each equation has no solution, one solution, or infinite solutions. Okay? So here's what we're going to do. Remember, if you are doing your steps, remember, don't call me after midnight. Don't call me after midnight. Distribute. Combine like terms. Move all variables to one side. Undo addition and subtraction. Undo multiplication and division. Okay? So let's look at each one individually. Negative 2x plus 3 equals negative 3x plus 2. Okay. So, our first step here, move all variables to one side. To move all variables to one side of the equation, I'm going to add 2x to both sides. Bam. 3 equals negative 1x plus 2. And you stop here. Because as soon as you see that you only have one term with a variable left, and there's nothing that could possibly get rid of that variable, it's immediately one solution. If you're going to have a variable left at the end, it's immediately one solution. So let's go to our second one. Negative 2x plus 3 equals negative 2x plus 3. So this one you could figure out by without even having to do any math, because it's the exact same equation. Negative 2x plus 3 equals negative 2x plus 3. It's the exact same line. If you graphed it, they would be on top of each other. That's infinite solutions. But let's talk more about what infinite solutions means. We start by moving all of our variables to one side. Add 2x, add 2x. You get 3 equals 3. Something can be infinite solutions when you don't have a variable left over in the end. In that case, you check the numbers. If the numbers match, it's true, and therefore is infinite solutions. Okay. Now we go to the last one. Negative 2x plus 3 equals 2x plus 3. Okay? And this is something they're going to try to trip you up on. Okay? Because you already have an answer of one solution. You already have an answer of infinite solutions. So your mind's going to say, okay, the third one's going to be no solution. No, it's not. Because if you add 2x to both sides, you're left with 3 equals 4x, because these don't cancel out, because 2 plus 2 is 4, plus 3. And you're left with a variable. You have a variable. It's immediately one solution. The only time it is no solution is if you get to this point where you have no variables left and your numbers are different. For example, if you had 7 equals 4, that doesn't work. That's no solution. Okay? Let's go to question 11. Question 11 I actually want to cover in class, so I'm going to skip that one. Question 12, this would be the same process. Solve the equations. Okay? I'm not going to go through and solve each equation just because I see we're already 35 minutes into this. So I want to make sure that we have time to get through as many questions as possible in this hour. So I'm only going to solve the correct equation, which would be equation A. 3x plus 1 equals 3x minus 1. So what happens here? You subtract 3x from both sides, Because remember, our step here is move all variables to the same side of the equation. That cancels that. That cancels that. You're left with 1 equals -1. Does 1 equal -1? No. So it's no solution. And it's A. If you want to double check yourself, you can always just do B, C, and D, but they would all work out to either be 1 or infinite solutions. Okay, question 13. Brett creates a function of x with 7 points. Function, keyword, each in a different location on the grid. He graphs 6 of the points as shown. Use the add point tool to show the location of a point that could be the 7th point of Brett's function. So remember, function, we gave it a long definition during the functions unit about, like, a relation where every input x only has one corresponding output y, which is a great definition to know. But for the purpose of the state test, when you see function, x doesn't repeat. You're thinking of either vertical line test or x doesn't repeat. The vertical line test being the whole thing where you make a line, you make a vertical line, and you run it over your graph and see if it ever touches the graph twice at the same time. Here, this is a function because it never does. So, all you're going to do is you're going to take one point, one single point, and you're going to put it on an x that doesn't already have a number on it. For example, right here. X equals 3, doesn't have a number, doesn't have a dot on it already. So if you take the vertical line, it's good, it's good, it's good, it's good, it's good, it's good, it's good. You can put it on any single square that is not in the column of x equals 0, x equals 1, x equals 2, x equals 5, x equals 7, or x equals 8. So you can put it in 3, 4, or 6. Any spot in column 3, 4, or 6. Anywhere. And it has to be on the graph. You can't put it out here. Can't do that. That's wrong. Okay. Question 14. Isosceles trapezoid ABCD is shown. It is rotated to create EFGH. So, I'm not even going to rotate it. Here's what you need to know about polygons. When you name polygons, especially when you're comparing two polygons, you need to, alphabetical order matters. So here, A is here. E is your first letter here. So E has to be there. B is here. It's the second letter. So F has to be here. C, the third letter, is here. So G, the third letter, has to be here. D, the fourth letter, is here. So H, the fourth letter, has to be here. Okay? Before you even get into any rotation shenanigans or anything like that, just draw the shape first. Okay? Then you can worry about rotating it if you have to. But you might not even need to do that. For example, which statement is true? A, line EF, which is this line right here, is parallel to line HG. And you can see that that's not true. They would eventually cross up. Okay? So let's get rid of those. Cross that out. Angle A is congruent to angle F. So if you look on this, on the original shape, I'm going to zoom in so you can see it better. This has one hash mark. This has one hash mark. That means that these two angles are congruent. This has two hash marks, as does this. So these two angles are congruent. But since they have different hash marks, this angle B and angle A are not congruent because they have a different number of hash marks, which means that angle A and angle F would not be, nor would angle B and angle H, which means we're only left with one possible choice, which would be line FG is parallel to EH, which you can see in here by these arrows that they are parallel. So that is your correct answer. Question 15. An incomplete sentence is given. The value of 2 times 10 to the 14 is blank times the value of 4 times 10 to the 6. What number correctly completes this sentence? So when you see is blank times, you're thinking division. 2 times 10 to the 14 divided by 4 times 10 to the 6. Okay? So we're going to open our calculator. And we're going to do 2 times 10 to the 14. Remember, keep those in parentheses. Divided by 4 times 10 to the 6. And it's going to give us the answer of 50 million. And if you wanted to, you could just put 50 million in. 50 million. Just make sure you count your zeros. Make sure you're putting in the exact same amount of zeros. And that'll be it. Okay? You could also convert it to scientific notation if you want to. So remember to convert 50 million to scientific notation in case you need a refresher. You stick your decimal point after your first number, and you count how many spaces are after that. So this would be 5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 10 to the 7. So this is also an answer. Okay? Or you could just put in 50 million. The state says you could just put in 50 million. Just put in 50 million. That's what the calculator told you. Okay? All right. Let's go to question 16. A scatter plot of some data is shown. What model best represents the data? So what this is looking for is what we call a line of best fit. And the way a line of best fit works is that the goal is to try to get a line that is as close to as many points of the data as possible. What it's trying to do is it's trying to predict what the slope of the line would be if it wanted to model it as a linear equation. So all you're looking for is which of these has a line that's about the average of the points. So C, immediately gone. That's a horizontal line that does a terrible job of representing your data, so it's gone. B, also, B is better than C, but still pretty bad. You have some points that are decently far away from the line, and that's on more than one occasion. So I would say B is gone. A, all of your points are below the line. You have nothing above the line. Remember, you want something that looks like an average. So you want some above and some below. So take out A. That leaves D. D has some points below the line. It has some points above the line, but not by much. And it even has some points on the line. D is it. That's what you want. Question 17. What is the distance between 1, 3 and 13, 8 on the coordinate plane? So this doesn't look like it. This is a Pythagorean theorem problem. Okay? So you would have like 1, 3, 13, 8 would be like way up here. And it's asking you for the length of this line. And what you can figure out is how far you had to move along the x-axis by doing 13 minus 1, which would be 12. And how long you had to move on the y-axis, which would be 8 minus 3, or 5. And then it becomes Pythagorean theorem. A squared plus b squared equals c squared. 5 squared plus 12 squared equals x squared. So you could even go into the calculator, go in 5 squared plus 12 squared equals 169 equals x squared. Remember to take the square root. Square root of 169 is exactly 13 equals x. And that's it. This distance would then be 13. Done. All right, an expression is given. Select all the expressions that are equivalent to the given expression. So this is, to make it easier to read, 3 to the second raised to the third times 3 to the 6 over 3 to the 4. This requires a variety of exponent rules that we've learned. So remember your exponent rules. You have the product rule, which is x to the m times x to the n is equal to x to the m plus n. You have the quotient rule, which is x to the m divided by x to the n equals x to the m minus n. And you have the power rule, which is x to the m raised to the n is equal to x to the m times n. Think distribution for this one. Okay? And what this is asking you to do is use your exponent rules. Remember, you want to go in order of operations order. So go one step at a time. 3 squared times 3. So we have 3 squared raised to the third. So we're going to multiply our exponents. That's 3 to the 2 times 3, which is 6, times 3 to the 6. I don't know why I drew this parentheses. That's why I had to pause for a second because I don't know what I was writing that for. Over 3 to the 4. That's our first step. Are any of our choices this? No. Cool. So now we do product rule because we have to resolve our top. 3 to the 6 times 3 to the 6, we add our exponents. That's 3 to the 12 over 3 to the 4. Is that one of our choices? Yes. Okay. Then we do quotient rule. 3 to the 12th divided by 3 to the 4th is equal to 3 to the 12 minus 4. 12 minus 4 is 8. Is that one of our choices? Yes. So, here's another way you could do it. And this way, if you want to do it this way, you have to be very, very careful. So you're going to do 3 squared raised to the third. Whoops. Times 3 to the 6. I actually haven't even tried this in the calculator yet, so I'm not even sure if this will work. We're going to find out together, y'all. All divided by 3 to the 4. And that would give you... Oh, yep, nope, would not work. Well, we tried, everybody. We tried. What is syntaxing about that? That doesn't like that. I don't know. I don't know why it doesn't like that. Oh, it's probably that. Hey, 6561. So it gives you 6561. So now you can go in, look at each of your choices. 3 to the third. Is that 6561? No. 3 to the 7. Is that 6561? No. 3 to the 8th. Is that 6561? Yes. Check it. 3 to the 12. Divided by 3 to the 4. Is that 6561? Yes. Check it. 3 to the 11. Divided by 3 to the 4. Is that 6561? No, don't check it. Done. Question 19. Table of functions. A table of values for function A and the graph function B are shown. Okay, create an equation for the third linear function with a rate of change that's between the rates of change for functions A and B. So what you need to do is you need to find the rate of change. So here we go. We're going to do the same way we did in the first problem. For the table, -4 to 2, that's plus 6. 2 to 4 is plus 2. -2 to 2.5, ooh, that's a tough one. That's plus 4.5. You can put that in the calculator, 2.5 minus -2. Remember, always use parentheses with negatives. And then 2.5 to 4, that's a jump of 1.5. Function B is a little bit more tricky, mainly because how it's displaying on my iPad, you can't see the grid very well, but you would have to find the slope. The way you would find the slope would be if you did rise over run. So I'm going to see if I could try to find 2 points on here. This is going to be difficult. We have a point at 0, 3, and we have a point at 1, 2, 3, 4, up 1. We have a point here. Okay. At 3, 4. This would be 3, 4. This would be 0, 3. All right. See, I'm silly because I could just use the version of the test that I have printed out. But so there's a point at 5, 5 and a point at 0, 3. So you would go rise over run. Okay. Draw your line. Draw your line. 5, 5. That would be an increase of 2. An increase of 5. So your slope would be 2 over 5 or 0.4. Here on function A, your slope would be 1.5 divided by 2 or 0.75. Okay. So with that information, we know that it has to be bigger than 0.4, smaller than 0.75. Create an equation for the third linear function with the rate of change that is between the rates of function A and B. So, do you need a y-intercept? Absolutely not. All you need to do is write an equation where you have a slope that's bigger than 0.4 and smaller than 0.75, which would be, for example, 0.5x. That's it. Done. Let's go to question 20. Two quadrilaterals are shown. Brian uses two transformations to show the quadrilateral JKLM is similar to quadrilateral WXYZ. What transformations did Brian use? Okay, so you can immediately see our new quadrilateral is bigger than our old one, which means that it has to have a dilation. Any choice that does not have a dilation is now eliminated. Okay? So what I would do now is I would draw new quadrilateral, WXYZ, without any transformations on it. So remember I said that it has to stay in the order. J goes with W. K goes with X. L goes with Y. M goes with Z. Okay? And you have to be able to picture how this would look. Okay? So let's look at our choices. Let's start from the bottom up. Dilation and translation. Okay? Translation is a shift. So translation A, B, C, D would be like moving this way, and it would still be A, B, C, D. We call it a slide. Because of the SL in translation, we think slide. You'll notice that the order of the letters did not change. So the fact that the order of the letters changed between this shape and this shape says it's not a translation. Now let's look at reflection. Reflection involves flipping. We talked about that way back in question 1. So if you have A, B, C, you would now have A prime, B prime, and C prime. You'll notice that the letters are backwards. They're flipped. Mainly, the ones that are vertical from each other are still vertical from each other. So this suggests to me that it is a reflection, specifically over the y-axis. A rotation would have a situation where if you rotated this shape, this Nintendo Switch looking shape, let's say you rotate it 90 degrees, everything would shift one spot in the order. So instead of W here, X here, you would have W here, X here, and everything shifts one over. And that doesn't work. So it is dilation and reflection. Question 21. I'll go over in class. Actually, the last 5 of these, because I'm looking at the time, I'm going to go over the last 5 of these in class. So bring your paper to class, and I will go over them. There. But thank you for taking the time to watch and follow along with this video. I will see you when we're in class. See you then.